So the create keyword. All right, so what are we going to do here? Okay, so when we create a table, we're going to use the create table. Let me kind of draw this out. So first, this is the keyword that we're learning. This is the create keyword. And if you want to create a table, then you use the table keyword. And then table here, right, is this is basically the name of the table. So whatever, we'll just say table name. Okay, so just wanted to clarify that. Another thing to keep in mind, which would give you errors when you're first doing this, is that you need these commas, right? But in the last sort of line before your closing parentheses, you do not want a comma here, right? So no comma there, but make sure that you do have a comma after each line, right? And then what are we doing here? We have two column names and then a type and then a column constraint. So we're going to go over this step by step. So first you come up with a name, and maybe this might be a primary key. So we might think of this as like customer ID, right? Something like customer ID. Let's just say, just write that here. And then serial is really good for primary keys. And we'll talk a little bit about that. So we'd use the serial data type, and then you'd have a constraint here, right? And that constraint would be, in this case, primary key. And that primary key will give you sort of an auto incrementing. It'll make sure there's no null values, and it'll also handle any instances where you have to delete or add a record. It'll make sure that the relationship is preserved. And so all you really need to think about is the serial data type and then the constraint primary key. And it kind of takes care of that for us. So let's look at the next column. So this next column, that could be, I don't know, maybe something like, it could be name, and then you'd have to think about the data type that you use for name, right? And the length of that. So maybe varchar, and then maybe 50 characters, and then a constraint here. Do you want that to be unique, right? If it's a name, it should be, if it's a username, it should be unique, right? So maybe this is username. And then it should be unique and maybe not null. So you could use those two. So you can use unique and not null. And then you would add a comma. Okay, so let's move on to the next part. And the table constraint, again, this deals with the whole table, and we're going to talk about that later. And the same with inherits. This has to do with the existing table relationships with primary keys and foreign keys, and preserving those relationships. All right, so serial is important because one of the first things you do is that you need to create some sort of a primary key. So here we have create table, and we're just like we did before, very simple example of creating a table. Again, you use the create keyword, and then if you're going to create a table, you would add that, and then you come up with the table name, right? And so serial is notation for creating unique identifier columns. So this is a screen grab from the documentation, and you can see that it says auto incrementing integer. And this is how much it does that, and this is the bytes. So we're not going to get too much into the storage size, but I did want to point out that it is an auto incrementing integer. So it's really great for creating unique identifier columns like primary keys. And here we have, let's say, an example where we're creating a table and we're using a customer ID, right? And then what do we want to do? Serial, that's what we want to add, is the data type. And if we want to add another column, maybe we want to add, let's say, an account, right? So small int, let's go back to that. So small int, let's say we're asking maybe how many accounts does the person have? Maybe, I don't know what that exactly means, but let's just say it's a small number, right? So let's take a look at this example from the documentation. So where is small int? Here it is. And what does it say? It's a small range integer. So it's going to be anything that's going to be negative to positive integers. And so this is going to be more than enough to handle how many accounts this person has. Okay. And if you wanted something that had maybe more digits, what is it? 1, 2, 3, 4, 5. So this is 5 digits, but this one is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you needed more than 5 digits, maybe you'd use an integer. Or if you really needed like maybe a phone number or something much larger than that, then you might use a big int, right? So this is kind of giving you an idea of what values and what sizes and ranges that we're dealing with. And then we have decimal, numeric, real, and there's double precision, small serial, and then big serial, right? Depending on the sizes that you need for your IDs. All right, so let's move on to the next example. And what are we doing here? We're creating an accounts. And let's go over this little by little, part by part. So customer ID is a primary key. We're going to be using the serial data type, and this is the constraint that we're going to give that. And here, similarly, this is the name of the column, which is accounts, and the small integer because it's going to say like maybe 3 accounts, and it can't be null. We need to know how many accounts this person has, this customer has. And so this is a very simple way of creating a table. However, there is a mistake here, and there should not be a comma on the last line. That was a mistake, but I like to turn this into an opportunity because you'll get this error if you add that. So it has to be a comma after every line, but not on the last line. Okay, let's move on to the next part. Okay, again, here, this is a reference from the documentation, and definitely refer to the documentation as you're creating your tables. This is always very useful depending on the use case. And then again, think back to the earlier slides where we said, think long-term, right? So really think about how big this number has to be depending on your use case. Is it going to grow to the point where it can't be a small int? Maybe it needs to be an integer or a big int. So these considerations are really useful when you're taking a look at the documentation. It will really give you some information on the range, a little bit of a description, and storage size if that's something that's important for you. So we've covered the high-level overview of how to create a database. We took a look at the syntax, and in the next video, we're going to use the create keyword and the table keyword to create our tables. Now we're ready to create our database using the create keyword and the table keyword. We've already explored the concepts and you checked out the syntax in the last video. So in this video, we're going to dive into creating our table. All right, let's get started. Okay, so we're ready to jump into pgAdmin and let's go ahead and create our database. So first what we want to do is we're going to go to databases here, and we're going to create a database, and this could be anything that you want. So I'm going to say DB example, but this could be whatever, whatever it makes sense for you when you're creating your database. So let's go ahead and save that. And where is the database? Let me minimize this. There it is, DB example. So I'm going to go ahead and refresh this. Okay, and I'm going to right click on this and go to the query tool. Okay, so it seems like I'm inside of the query tool, and you can see DB examples, the database name up here. So if I were to select everything, and there's no table, right? So we need to first create a table. So we can't even perform a select statement yet. So let's go ahead and create a table. Let's create a table. First of all, let's think about what we're trying to do. So let's think of what table we're going to create in tables, right? So let's create maybe a membership table, and then another table could be a gold member table, and then another one could be like a member rewards or rewards membership or something like that. So those are 3 tables. So the first table would be membership. So okay, so let's create a membership table and think about what that might need, and then think about the proper data type and then the constraints. All right, let's try this. So first what we're going to do is use the create keyword. And what are we doing? Well, we're creating a table, and let's call that membership or members. No, membership is fine. Okay, so here is our, I had a semicolon there, and let me just open this up. And first what I'm going to do is I'm going to say, okay, well, we need a primary key. So what could this be? Well, this could be member underscore ID. And that would be the name of the column. Okay, how about data type? Well, we know that we're going to use serial. So we've already talked about serial data type. And what is this? Well, this is a primary key. All right, great. And then we have to add the comma, right? Okay, so this is the first thing that we've created. So member ID, that's the first column, I mean, and which is member ID. It's a serial data type, and the constraint is primary key. All right. Next, we want to create, since this is for a member ID, well, username is a good one. And what do we need here? So this could be, since it's we're going to use varchar because it's going to be, we don't know how big it's going to be. It could, different usernames are going to be different sizes. So we want to use a variable character data type. And let's say 50 is going to be enough for a username. And we want to add some constraints. So usernames should be unique. So let's say unique. And we don't want them to be null. So let's say not null. Okay. Pretty straightforward so far. All right, so let's go to the next one. And the next one's password, because a username has to have a password. And we'll do the same thing with varchar. And 50, let me see. 50 is also going to be good. That's big enough. And we don't want this to be null. And we're not going to check for unique passwords because maybe two people have unique passwords. That would be weird, but we're not going to check for unique passwords. We're just going to say that it can't be null. It can't be blank. It can't be a missing value. And let's say email is the next one. And we can also do varchar for the data type here. And let's say 200 in case I have a really long email. And we can say unique. And because the email should be unique, we don't want duplicated emails. And then not null. We don't want this to be empty for sure. And let's add member since. So how long have they been a member? Well, we can do a timestamp for when they became a member and make sure that that's not null. And we're going to add one more column. Let's say the last time they last login or last visit. And this can be a timestamp. I'm not going to add a comma here. And I think these last two are important. So this is when they created their account, when they became a member. And maybe we need to keep track of that. If they're a member for a year, maybe they get some sort of a benefit. And last visit is just a timestamp showing the last time they logged in and accessed their account. Okay, so let's see. This should be everything. So let's go ahead and run this and see if it works. All right, returned successfully in 84 milliseconds. Okay, so what does that mean? Let me refresh this DB example and let's see if we have something new. Let's go to schemas. Here are public relationships. Let's go to tables. And there's our membership table. Awesome. Okay, so before we create any other tables, let's go ahead and select everything from our new table from membership. Okay, semicolon, and then run that. Cool, there is our table. We can see that we have a primary key right here, and we have a username, password, email, member since is going to be a timestamp without a time zone. Same thing for last visit. Okay, so this is looking pretty cool. They're all empty though, so we need to populate those, but we're not going to worry about that right now. Let's go ahead. That's going to be in the manipulating database section in the next set of videos. So let's create two more tables before we leave here and go to the next videos. So let's create a gold member table. All right, so first we use the create keyword and we're going to say table, and the name of this table is gold member. All right, and we're going to add the semicolon so we don't forget later. And here I'm indented and I'm going to say, well, let's add a primary key. I'm going to call this gold ID, and the data type, what do you think it's going to be? Serial. Cool. Hopefully you got that right. And what is this? What ID is this? This auto incrementing ID? It's a primary key, and that's our primary key constraint that we're adding here, just like we had with member ID down here. Okay, so that's our first column. Let's create one more, which is level. Like, what level of gold member are they, right? So, and I don't know, I'm just making this up, right? This is a fictitious membership table. So let's say we wanted to do varchar again and 25 because the level is not going to be that big. And the level could be text. So let's leave it like that. And we don't want this to be null. We need to know what level they're on. And I think that's it. So I'm not going to add a comma here. I've got a comma here. I don't have a comma here. And I think that should work. So let's go ahead and create this table. Okay, it says created successfully. I don't see it here, but I'm going to go ahead and refresh this. And then we should see another table. Let me see. There it is, gold member. Cool. So we could do the same thing. We can say select everything from, and then we're going to say gold member. All right, and then let's run that, semicolon. Okay, so we have our primary ID and the level for that membership, for that gold membership. Maybe they have multiple tiers and multiple levels. All right, so let's create one more table. And this table, let's say member rewards or something like that. So let's create a table. And we're going to say this is member rewards. Rewards. Okay, there we go. Parentheses, I'm going to add the semicolon so I don't forget. And I'm going to indent. And member ID seems like a pretty straightforward one. And again, this is going to be, let's not create a primary key here. This is going to contain other, this is going to be a reference table. So let's say integer. And this is a reference that we're creating. So we're going to use the references keyword. And what is the reference that we're making? The reference here is membership and member underscore ID. So let's talk about that. Well, the membership table here, let's go to columns and then member ID. So what we're saying is that member ID, we're going to have a member ID here. So this membership ID is going to be a member ID here, and it's going to be whatever this member ID is. So that's the relationship, and that's how you would create that relationship. And once we have all of this created, we're going to take a look. You can actually right click on it and then look at the relationship, or go to schemas and look at the constraints, and then you're going to see that there's a reference there. So that's what we did before in the constraint sections. And now that you can see the keywords that we're using, which is references, and then you're actually stating that reference. And in this case, it's membership with parentheses and member underscore ID inside. All right, so let's move on to the next one. And I also need a comma here, so don't forget that. All right, so let's grab gold ID. Let's create a membership there. So gold underscore ID, and it should also be integer. Okay, integer, and then we're going to do the same thing, references. And how do we connect this? So feel free to pause the video and try to figure out how we're going to create a reference to that gold ID. All right, so hopefully you figured it out. So we're going to call the name of the table, which is gold underscore member. And inside of the parentheses, we're going to actually mention that primary key in that table. So let's go to that table. We have columns, and it's gold ID. So let's grab that gold ID. And that relationship is now set. And it's the name of this ID inside of the member rewards table. Okay, let's add a comma and add one more so that this makes a little more sense. Maybe we want an award date. Maybe they got some sort of a reward or an award. Maybe it should be reward date, right? Or no, an award is something that, I don't know. Let's just leave award date. And all we want is a timestamp. And this doesn't need to be not null. It can just, it can be blank if there's no, if they've never received any award. And I'm not going to add a comma here. I'm just going to leave it like this. And then I'm going to run this, and it created successfully. All right. So let's see if we have that third table. I'm going to click on refresh. and we have gold member. There it is, member rewards. That's what we just created here. All right. So we created 3 tables, and we thought about the data types. We added some constraints. We used the proper keywords with using create table and the name of that table, red parentheses, semicolon. So your syntax is now has expanded for creating a table inside of a database. In the next set of videos, we're actually going to add records and manipulate the data that's inside of these tables, right? So right now it's blank. If you were to select everything from any one of these 3 tables, there'd be nothing in there. So we're going to cover how to add information, how to drop information, and how these keywords work to manipulate data that's inside of a table, inside of your database. In this final set of videos, we're going to dive into manipulating the database and the tables that we've created. So let's take a look at what we're going to learn in this set of videos. This is an introduction to manipulating databases, and so far we've talked about data types, primary and foreign keys, database constraints, and then we use the create and table keywords to create tables. You may have heard about CRUD, but if not, I'll explain it and I'll give you an explanation in the context of SQL. CRUD is an operation that is used for building applications. So this is you may have heard of REST APIs or different APIs, and they have this functionality called CRUD, which is basically create, read, update, and delete. And in SQL, that actually means, and these are the keywords that we're going to be using. So insert, select, update, and delete. So we'll start with inserting data, then we'll select that data, then we'll update the data, and then delete the data. So these are representations of CRUD operations, but in SQL. The only difference is that they have different keywords and they're called different things. So in this set of videos, what we're going to learn is how to use the insert keyword to insert records, and the update keyword to update basically our records. And this is all just very semantic. We're going to delete records, alter records, and then drop records. We're going to go through each one of these and talk about them in a high-level overview and also go into the syntax. Then we'll dive into pgAdmin and take a look at how all of these keywords work to manipulate our database. So here's the syntax for an insert statement. So we're going to insert into a table, and so this would be the table name, and here are column names, as many as you need. And then we're going to use the values keyword here to insert those values, and then you can just specify what those values are. And this is pretty straightforward. We'll get into this in pgAdmin, but let's continue taking a look at the syntax. So consider the data types and constraints for both tables. So here we're talking about inserting from another table. So you can insert records like we did in the last syntax example, where you're just entering values that don't come from anywhere, that you're actually just inserting into that table. But here what we're doing is we're inserting into a table, and here are the columns that we're looking at, and we're going to select these columns from this table, and then you can also specify a condition. And basically what we're doing is we are inserting records from another table. So again, I'm going to read this bottom part. So consider the data types and constraints for both tables. So this should make more sense, because what we're doing is we're working with other tables, and they must match. And serial columns don't require values to be added because they're auto incrementing and they kind of take care of themselves. But the key words are they must match, or you will get an error. Okay, so let's jump into pgAdmin and then insert some values into our new database and tables. Okay, so here we have pgAdmin, and let's go ahead and take a look at the membership table. So just select everything from membership, semicolon, and what do we get? Okay, so currently it's empty. So let's add some values. So what can we do here? So let's just say insert, right? This is what we just learned. Insert into, and then the table name, which is membership. And what columns are we going to be inserting into? Well, here we can see username, password. Again, we're not going to be working with the member underscore ID because it's a primary key and it's a serial data type that's auto incrementing. Okay, just wanted to point that out. Okay, so we're going to jump into username. So let's say username and password, email, and member underscore since. All right, so that looks, password, there we go. Email, member since. Okay, so that looks good. And we're not going to add anything to the timestamp because the last visit is something that will happen whenever they do that. They'll sort of add those values as they use their account. Okay, so now we need to use the values keyword. And we're just going to hit enter and then indent and then use some parentheses. And here we're just going to add a username. We'll just say Nance. And the password is going to be, just for this example, password. And we're going to give it our user an email. So Nance at, let's say, emails.com. I just made that up. It probably exists, but it's just some fake email I just made up. And then here we're going to add current timestamp. So when we do this, it's going to give, this is a special keyword that will input the current timestamp right now. Whatever it is, whenever we run this, that's when that timestamp is going to take place. And it's going to add a timestamp that makes sense and it matches the data type of member since. All right, and I think that's everything. So let's go ahead. If everything worked, let's go ahead and run this. Okay, so we have an error. So well, I misspelled, that's why, typo, membership. Okay, membership does not exist. That was a good error. So let's try it again. All right, it returned, it was query returned successfully in 103 milliseconds. So a little bit longer because we added some data, I guess. And now if you want to take a look at this, we could just say, select everything from member. What is it? Membership. Yeah, membership. All right, so let's see what we have. And check that out. We have, so this is kind of cool, right? The member underscore ID created the one for us. And that's what I mean by auto incrementing. We don't have to do anything. It adds that value for us. And then we have Nance as the username, password is password, not a best practice. Email, Nance at emails.com, and there's that timestamp. So you can see exactly what date it is today. It's the 28th of February, and this is the time. So we have 3:12 p.m. 59 seconds, and then a really specific time. So last visit does not have a not null constraint. Otherwise, this would not have worked, right? So we left that as undefined constraint because whenever the customer logs in, then we'll be able to see their last visit. Okay, cool. So that was pretty cool. That worked. Nice. So let's add some data from another table just to see how that works. So let's go ahead and take a look at gold member. And let's run that. Okay, we have two columns, gold underscore ID and level. So how do we add information? So let's try to do that. Let's just add information directly into this without doing it from another table. I think that'll be a little bit more complicated. So let's just say insert into, and then the table name, which is gold member. And we're going to select the column, which is level. And we're going to use the values keyword and then indent on the new line and say level 42, something like that. And let's go ahead and run that. Okay, so that worked. So we see the insert 01. So the first column it didn't insert anything and the second column it did. And let's go ahead and check that out. Cool. So the auto incrementing primary key worked, and now we have level 42. How about if you wanted to add another value into gold member? Let's do that again. So we can just This time we'll just say level, and we just want to add another one like, I don't know, platinum is a level. That could be a level. Okay, so let's add that into that table. Okay, it says it succeeded, returned successfully in 65 milliseconds. Let's go ahead and look at that. Cool. So you see auto incrementing. Now we have number 2. Pretty cool. And platinum is some sort of a level. So we have level 42 and then platinum level. And let's insert into the members rewards table. So how do we do that? So let's go ahead and just look at that table. So let me just go ahead and go to member rewards, member underscore rewards, member underscore rewards. Let's go ahead and take a look at that. Okay, so we have 3 columns, no data. So let's add something. So we're just going to say, how do we insert something? Insert into keywords, insert into the table name, which is member rewards, and the name of the columns, which is member underscore ID, gold underscore ID, and award underscore date. Okay, that looks good to me. And again, how do we add these values in there? The values keyword. Go to a new line, indent, and we'll use the parentheses to add the data. So the first member ID, this is an integer again, so we don't have, this is not auto incrementing, so we can add, let's add 1 to that. And then we'll add 1 to gold ID as well. And then let's just add the current timestamp. Okay, so that looks pretty straightforward. Let's go ahead and run that, and it worked. So let's go ahead and go back to the very beginning and take a look at the member rewards table. And we have 1, 1, and then the timestamp that we entered. Okay, so that was our first example of manipulating the database using the insert into keywords by adding values into the table that we created inside of our database. Okay, so next up, we're going to dive into more keywords and continue manipulating the database. Let's continue our journey into manipulating the database, and this time we're going to dive into the update keyword. Let's take a look at the syntax first. Update. So what are we going to do here? So here's the syntax. Let's take a look at this before we actually jump into pgAdmin. So we're going to update, and then that's the keyword, and then the table name. And then we use the set keyword, and then we define the column and then the value, right? And this is for existing data. And so you have another column and then another value. And then you can also use the where key to add a condition, which is really, really useful. So let's dive into that. So here we have the update membership. So this is the table, and we're going to say set, and notice this warning symbol. What do you think is going to happen if you do this? So set last visit equal current timestamp. So we're not using a where clause to sort of evaluate a condition. And so what this is going to do is take every value in the last visit column, as many as they are, and then add 1 timestamp all at one time. And I don't know if that's what you want to do. I mean, if you do, well, then it's very powerful. However, this is very powerful, and we do not want to do this. We only want to do that where maybe there's no values. And that's where you can use the where keyword. So let's look at that example. Okay, so here, now we have the green arrow. Things are better. So we have the update keyword, and this is the name of the table, and we're going to set last visit to equal the current timestamp, where last visit is null. So this is only going to add this timestamp to remove null values. And that makes sense, right? And you can change the where clause to any kind of a condition that makes sense for what you're doing. It could be null values, it could be zeros, or anything. So it's very, very flexible because you have a where clause, and you're going to update values in a column, and you can do them all at once, or you can just do a few based on a certain condition. So It's kind of powerful, very flexible, but you have to keep that in mind when you're using some of these keywords. They're very powerful, and you don't want to replace everything in the database to one value by accident. So the where clause is very useful. And here we have an example of how to update from another column. So what's happening here? Well, again, update, membership, table name, and then the set keyword. And we're going to say last visit equals member underscore since. So you can update from another column. All right. So again, very powerful, and make sure that it makes sense to do that. So because it will do that for every value. And here we have some more syntax, and this is sometimes called a silent join, and I can explain that. So here's the update keyword, and here's our table, and we're going to set the original column equals, and then table name, and then a new column. So you can change one column to another column from another table, right? And here again, we're using that dot notation like we did when we were joining, and here is the silent join, where table 1 ID equals table 2 ID. And so this is sort of like the on keyword when we're doing a join, and that's why it's similar to joins and why it's called a silent join. So this is another possibility when you're using the join, when you're updating tables and you're performing this silent join. Here we have this very similar example, except that we have this returning keyword. And what this does, it'll return all of the values that were affected, in a sense, giving us a little bit of feedback on like what just happened. Otherwise, it'd be like, we performed this in 15 milliseconds, updated. What was updated? And so returning will actually tell you what was updated, which is kind of nice. And that's why I wanted to show you that syntax and these syntax examples. All right, jump into pgAdmin and then add the final syntax here. So what are we going to do? Let's go ahead and select everything from membership. Oops, from membership, like this. And let's go ahead and run that. Okay, so we have one record. And what do we want to do? Well, maybe we want to set every null value for last visit with a current timestamp, right? Because we have a null value. Let's say that's what we wanted to do. And this is a great use of the update keyword. So all you have to say is update, and then membership, and then the set keyword, and then what is the column? Last underscore visit. And what are we going to replace it with? The current timestamp. Okay, so let's go ahead and say we don't want to do that. Let's say we had 10,000 records. We don't want to do that to all of them. We only want to do that to null values. So that's where you would use the where clause to say last underscore visit. And here's the condition, is null. So if it's null, add the timestamp. Timestamp. Oops. Okay, so that was a typo. So this should work. Okay, so it returned successfully in 68 milliseconds. And if you want to look at that, let's go to the query history, grab that membership, and just run that. And boom, there it is. So today is the same date. Now it's 3:30. Okay, so it gives us the current timestamp. All right, so this is pretty cool. So that this is working well. So let's go ahead and grab the query editor and query history and just kind of update, just keep going from here. So now what we're going to do is just update membership, and we want to set, let's say we want this column to now have this value. Okay, so we talked about that. So how could you do that? Well, that would be last underscore visit equals member since, not cap, like that. Member since, and so this value is not going to be here. All right, so let's see if that works. All right, and let's go to the query history and just grab this, copy to editor, and so you can see they're the identical timestamps. All right, so we successfully changed that. In the last one, we can do, let's do that silent join. So let's go ahead and check out member rewards. So member underscore rewards. And we have 1 row and 3 columns. And what we want to do is update. We're going to take member rewards and update the award date here. And let's grab that from member underscore rewards. And let's use the member since that we updated just now. Okay, so let's do that. So the way to do that is update member rewards. And then we're going to set, and then award date equals, and this is what, so what's happening here. So this is the award date right here. This is what we're going to change. And what are we going to change it with? Well, we're going to mention the table, what table membership. And then dot notation, and then member since. That's what we're going to replace it with, right? So that's what we were working with previously. So let's go ahead and replace that, that value from that table in this column. Okay, and then we have to say from membership, right? So that's the table that we're working from. Did I spell that right? Yeah, membership. And we want to add a where clause, right? And that's that silent join. So we're going to say member underscore rewards and member underscore ID. Okay, so that's from the member rewards and member underscore ID, right? So that's how we're joining. And we're going to join on what? So membership dot member underscore ID. And we have member underscore ID in this table, and we also have it in the membership table. And that's why this is a silent join. So let's go ahead and run this. Let me add a semicolon there. Oh, there. Member rewards. Okay. And that worked. So let's select everything from member rewards. Okay, and this timestamp is what we got from membership. Let me show you. So remember, it is the 28th at 3:12 p.m. And then it is 3:12 p.m. And so that was pretty cool. And if you wanted to do that, but you wanted to see what was changed, right? Because we didn't get to see that. Let me go to the query history and say, let me grab that here, update that. I'm not going to run this again because we already did it. But what we can do, let's go to select everything from membership. All right, so what we want to do is set the last visit to current timestamp. So we want to set this to the current timestamp, and we want to see what changes that we're making. So we're going to use the returning keyword. So let's try that. So we're going to say update membership, and that's the name of the table. And we're going to set last visit, that's this table, and we're going to say equals current timestamp. And returning. Okay, now this will show us what actually happens. So we're going to say member underscore ID, member since, and last underscore visit. Okay, so we're going to set the last visit value here to current timestamp. And if we had multiple, it would do that too. And we're going to return these values to see this. It's not caps. It's lowercase. So member ID here, member since, and then last visit. Okay, so let's run this and see what the behavior is. Okay, so we get member ID, member since, and then last visit. And you can see this changed, and you can see the time is correct. 1 minute later, so we were at the very end of that minute. And so returning is just going to show you what you want to see, and then you'll see what changed. So it's very, very, very useful. All right, so we're going to dive into the delete keyword next. All right, so how do we delete records? Let's take a look at the syntax. And this just is a reminder that you're going to delete. So delete from table where row ID equals 1. So this row will get deleted, right? If there's a match, there's going to be a deleted row. Now, this is a very powerful keyword because it can do multiple things. So let's check out some other examples. So here we have delete from the keywords and then the table name and then using table2. So this is kind of like a silent join but a silent delete. And every match, so where table ID equals table where table1.id equals table2 underscore ID. So this is kind of like the on, so like joining. So this is how we're creating that relationship. So any match from table 1 and table 2 that have that match the IDs, right? So if there's a match, it's going to delete. So this is very powerful, so just be careful when you're using this. So you will delete every match. Let's take a look at another syntax example. So here we have delete from table, and what this is going to do is, the reason that this is here is going to delete the whole table. So this will just be gone. Okay, so again, very powerful, but also, with great power comes great responsibility. You're going to delete the whole table. All right, so here we have with returning. So if you want to delete something from a table where the row ID underscore equals 1, well, use returning so that you can actually see, well, here's the row ID and here's the name, and I want to verify if I deleted that record, and you can see what you get back. Okay, so let's jump into pgAdmin and check this out. All right, so this is where we left off. Let's take a look at gold member table. So select everything from gold underscore member. And we have 2 rows. Okay, so let's see what we can do here. Let's add another value. We're going to insert. So insert into gold member. And then we're going to say level, because that's that's what we want to add. And the reason is, if you can remember why, this is kind of cool. The primary key is going to add the value for us. So the only column that we can work with is level. So I just wanted to point that out. All right, so let's continue here. And after level, we're going to add values, right? So I'm just going to go to new line, indent, add the parentheses, and let's just say silver. So we have platinum, we have silver. All right, this sort of makes sense. Let me run this and that. And we see that now we have that 3rd row. Let's say we wanted to delete that row, right? So it's kind of nice practice to add it and then delete it. So let's say delete from gold member. And we're going to say where, right? This is important. Level equals, and this is what we're saying. This is what we want to delete. Okay, if there's a match, delete it. But I do want to see what you're doing. So I want to see what the return statement is. And that's where you use the returning keyword. And you can say gold underscore ID and then level, right? And if you do this, boom, this is what got deleted. And that's because we're using the returning keyword, okay? And what happens if you do this one more time? Let's try it. Nothing, because nothing changed. So this is super cool. It's letting you know, hey, nothing was updated. And that's what the returning keyword does. All right, so let's continue our journey on manipulating the table in our database by checking out the alter keyword. Alter can do all kinds of stuff. It can alter the structure of a database. It can add, drop, or change column names. So let's take a look at the syntax, and then right after that, we'll jump into pgAdmin and put it to use and see how it actually behaves when you are entering SQL syntax. Okay, so the alter keyword is pretty powerful, and you can alter a table and then a table name and then some action. So this is the basic syntax. Let's dive a little bit deeper into the syntax. So here, what we're doing is alter table, right? So that's the keyword is alter, and then table is what we're altering, and this is the table name. And then what are we going to do? We're going to add a column. So alter works with other keywords, right? So you can drop, you can change column names. We'll explore all that, but just it's kind of like a keyword that works with other keywords. And so what are we going to do here? Add a column, and then we're going to add the column name and then the data type. So that's kind of important, but powerful too, right? So this is how you manipulate a table in a database. If you wanted to add a constraint or alter a constraint, you would use alter, and then what are you altering? A table. Here's the table name. And then you're going to alter column, right? And you're going to change the name, right? So that you're going to say, this is the column that I'm altering. Then you're going to add a constraint. So then you can add a constraint to that column. And what else can we do? You can also use a default value, meaning that you're going to alter a table, and here's a table name. And then you can say alter column, and then this is the column name. And then you can set default, and then that column will have default values. So you're going to create this new column, and then it'll have all these default values to whatever it is. It could be null, or it could be 0. There's different scenarios where it might make sense to have different values, like 100, and then it goes down, or 0, you start at 0, then it goes up, or there could be a keyword or a name. But anyway, the alter keyword allows you to set defaults, okay? And finally, we can add some more complexity. So alter the table name, alter a column. So we're creating a new column, and we're going to drop if it's not null, a very powerful keyword. And here we have same syntax, add a new column, and then set not null. So this is a constraint. So we're setting a table constraint that is going to be not null. And we're using the set keyword to set, and this is the actual constraint, right? So you can set constraints using alter and the set keyword. All right, let's jump into pgAdmin and try this out. Okay, so here we are, and let's go ahead and create a table first. So let's create a table so that we can kind of mess with that table and not destroy any of the other tables. So I'm just going to call this poll. This is a table called poll. And inside of this table, we add a semicolon here so I don't forget. I'm going to indent and say poll underscore ID, right? So that's going to be the first. This is a review of creating a table. So what are we going to do here? This is going to be our primary key. So what keyword would I use? And that's going to be serial. Hopefully you got that right. And what if this is a primary key? What do we write here? And we're going to write primary key. All right, so this is how we set that primary key. And let's create an address column, and we're going to say varchar variable character, and we're going to say 200 since it's an address. And let's set a constraint, not null. So we talked about that a little bit with the alter keyword, and this is what we're going to sort of practice with. And this next column, I'm going to call it participant, right, for like a poll. And again, varchar, and then 200 for the characters. And we're going to give it 2 constraints, not null, so it can't be null, and it must be unique. All right, the participant must not be null, and it must be unique. Okay, so each person that's participating in the poll must be unique. Okay, that makes sense. And no comma there. And let's go ahead and run this. And that seemed to have worked. So let's select everything from poll. Okay, great. We have our new table. So let's alter that table. So let's rename poll to something else. And we can say alter table. And then poll is the name of the table that we want to alter. And we're going to say rename to, and we're going to say district poll, for example. District poll. Okay, so rename. Okay, that seems to work. That seems accurate. So let's run that. Rename. Okay. Okay, so it returned successfully in 59 seconds. All right, so let's go ahead and return, select everything from district poll. It's no longer named poll. And if we were to do this with poll, we would get an error because it doesn't exist. Okay, so that worked. So what did we do? We changed the name from poll of the table from poll to district poll. Okay, so that's cool. So what else we can do? Rename a column. Let's try that. So alter, now this is called district poll underscore poll. And what we're going to do here is we're going to rename column this time. And let's change it from participants to respondent. And then we're going to use the keyword to, and then say respondent. All right, so let's try that. Okay, so that worked. And so let's go ahead and return everything. Let's go to the query history and just grab this, copy it, and then run that. And now it says respondent. Okay, so that's looking good. So everything is working. So how about if there's a constraint violation? So let's try that. Insert into, and then district underscore poll, and then address. Okay, so we're looking at this, which is a varchar, and then what was the so we said not null, so you couldn't put a null address in there. So let's try to mess with that constraint. So we're going to say values, and then indent, and then parentheses, and I'm going to say NA. Okay, so let's see what happens here. Okay, so it violates a non-null constraint. So failing rows contains either 1, NA, or null. So this is also a null value. And so you could actually use null, 1, any of these, and it would violate the constraint. So let's change that constraint. So that's the whole point of doing this. So alter table, then district underscore poll, alter, and then column. And we're going to alter that column respondent, and we're going to change drop not null. So we're going to allow null values. That's basically what we're saying. So the table is misspelled. District underscore poll, alter the column respondent, and we're going to drop the not null constraint. Okay, so this should work. Let's try that, and that worked. And what does that mean? So we've dropped that constraint. So if we added that column, it basically would work, but we can also add that again. So the way to do that is to use set. So right now we've dropped that so we could add null values, but if you wanted to set it again, you could do this. And so instead of going through the whole thing, I'm just showing that you can use the set keyword to set it, and then to drop it, you use drop. And let's test a new constraint. Let's say drop, so let's drop it again. I just wanted to show you that you could actually set it this way too. So let's go ahead and try to insert values again. So insert into district underscore poll, and the column is address. And what do we want to add? So values, new line, indent, parentheses, we're just going to say NA again, which we know that that will violate that constraint. And let's do that. And it worked because we dropped that constraint by altering it, right? And let's go ahead and just jump into, copy this to the query editor. And you can see that now that we have a null value, that was a constraint that we had that we sort of dropped using the alter keyword and the drop keyword. So that's it for the alter keyword. As you can see, it's very powerful and it works with other keywords like drop. And in the next video, we're going to dive into the drop keyword and explore that a little bit more. Okay, so what does the drop keyword do? We already know that you can alter the table and drop a constraint, but you could also drop a column. So that's what we have here: alter table, table name, drop the column, and then the column name. This will be a lot more clear when we jump into pgAdmin. So we could also add if exists. So here we are, our alter table and then table name, and we're going to drop column if it exists. Okay, let's see what else we have. Here we have some more, we can drop multiple columns. So here is alter table, and again, the table name, and then you say drop column, and then the column name, and then you have to have it's important to have the comma here, but in the last line, you do not want to have a comma, and you want to close it off with a semicolon. and that's the syntax there. So let's jump into pgAdmin and see how all of this works. Okay, so what are we going to do first? Let's check out district poll one more time. So we're here and we have a null value. And let's say we want to drop the respondent column. So let's do that. So we're going to alter table, and district underscore poll is the name of the table. And we're going to use the drop keyword and then column, because we're going to drop a column. And which column? Well, the name of the column is respondent. Like that. District poll respondent. All right, so let's try that. Okay, that worked. And we're going to select everything from member district poll, district underscore poll, and there is no respondent column. Okay, so that worked. Okay, so that's everything for the drop keyword. And next up, we have the check keyword. And we're going to dive into that. And that's going to be the last video for this course. So congratulations making it to the very end. All right, congratulations to making it to the last video in this course and series of videos. We've learned a lot of syntax for performing queries on a database and returning data and answering questions with the data that's inside of the database, inside of tables. And in the last several videos, we've explored how to create a database, how to create a table, and how to manipulate that table. And the final keyword we're going to explore today is check. Let's get started. All right, so check. What does it do? So here, and this is super interesting, we're going to create a table, and the table name, here's the bar ID, serial, and primary key, and we already know how to create that primary key, right? And here we're going to just create a small example, and it's going to be age, and it's a small int, right? And check the documentation if you're still unsure about small int. But here's the check keyword. And what we're going to do is to make sure that the age is over 21. Otherwise, so that's a constraint, right? So it'll check for that. It will not allow you to add that record if it doesn't pass, or if it's not over 21. So that's what it checks, right? So the check keyword is making sure it's kind of like I check your ID, right? That's the case here because we have age and it must be over 21. So let's dive into pgAdmin and see how this works. How does this work? So first, let's create a table. So we're going to create a table, and we're going to call it tiki bar, right? And let's give it some space, and then a semicolon. And the first thing what we're going to do is create a primary key, bar underscore ID, serial data type, and primary key. Okay, this creates we already know how to create the primary key, so I'm not going to go into that. And what I'm going to do here is, I guess this could be indented. And then birth date. And we're going to say that it's a data type. I think this is a new one. And we're going to make sure that it's not null, right? Because it's maybe a bar and then you need to check for age. So we're going to check age here. So age is a small int, and we're going to check if age is greater than 21. Okay, and I'm going to add a comma. And then finally, payment is an integer data type, and we're going to check if, and then maybe there's like a cover charge, right? So you're going to check if payment is greater or equal to 5, because it costs $5 to get in. Okay, so this should work. Hopefully there's no typos. Let's see. Okay, that worked. So let's select everything from tiki bar, tiki underscore bar, semicolon. Okay, so we have bar ID, birth date, age, and payment. So let's try to add some values, okay, and see if check works. So insert into tiki bar. Okay, so first we're going to add birth date and age and payment. So these are the column names, right? Usually they're inside of these. You're probably more accustomed to seeing it like this. right? And then grab this and put it like that. You could do it like that, but you could also do it the other way that I was doing that. So it's whatever is more comfortable for you. And then I'm going to just say values and then go to new line and indent and add the parentheses. And I'm going to say, actually, we're going to add the parentheses here. Okay. And I'm going to indent and say, well, the first value that I'd like to create, we're going straight to birth date. So I'm going to add that birth date. 1990 is the year, then the month, January, then the day, January 1st, 1990. And the second data type that I'm going to, or the second value that I'm going to add is 22 and then 4. All right. So I hope you see what's happening. The birth date, the age, and the payment. And the birth date is going to be a date and it can't be null. So that's okay. The age is 22. That's okay because it's over 21, but the payment is 4. So what do you think is going to happen there? Let's try to run this and see what happens. Okay, it didn't work. New row for relation tiki bar violates the check constraint because it's not over 5 or equal to 5. However, if we change this to 19 and then make this 5, or let's make this 10 so we know that it's over that constraint, we get the same thing, but this time it's saying the age check is not, so age is not correct. So let's fix that. And if we add the correct age and it's over $5, okay, so what's happening here? You have to be over 21. I should have said, I think I said over 21, greater than or equal to 21. That's what I should have said. So if I say 22, it'll work. So let's take a look at that. So we're going to select everything from Tiki Bar. Semicolon, and let's run that. Okay, so it's 22. So when you're writing that code, and let me grab that code again. Created a table, yeah, let's look at that. So all you have to do, just make sure that it works properly, is equal here. I'm not going to create it again, but that was my error, but now you know. So everything worked correctly, but I did make that mistake, but we did talk about it, so I think that was an opportunity there. All right, so that was a fun error. The check constraint works. It actually is very powerful, and it can check for, in this case, an age if you're over 21, or if you're over 22. But if it's greater than or equal to 21, then it can check if you're 21 or over. And if the price is 5, or if a value that it needs to be 5 or greater, then it'll check for that, and it'll give you an error and will not allow you to enter that data into the database, into the table. And that's what the check keyword does. Well, I had a great time in this course, and I hope you enjoyed it as well. SQL is a powerful tool, powerful programming language, and I hope you are able to work with data in a meaningful way. Again, I hope this has been informative, and I'd like to thank you for viewing.